Okay, hello everyone. First of all, thanks for coming and see my speech. I'm Luigi Fugaro, Solution Architect in Redis. And today we're going to talk about caching patterns. That's today's agenda. And we're going to see first caching, what is it, what it's all about. Then a little bit of, not introduction, but just a recap about software architecture, caching patterns, which is the main focus. And then, if we have time, a small demo. And then, if we still have time, Q&A session. And by the way, for the Q&A, you can interrupt me anytime you want, and I will try to answer your questions. So, okay, caching is everywhere. Actually, the first time when I started hearing about caching, it was back in the days in the 90s with Netscape Navigator, caching pages, images, history, then clearing everything for personal reason, for performance reason, for anything. But that was the first time that I heard about cache. The second time was when I actually, from my, let's say, soft skills about surfing the web, I then focused on the hardware. And then where I found the CPUs with caching, CPU level, L1, L2. And also, we can see here a caching pattern, which is the write back that we will see later. And then, when I started working, I started actually as a webmaster. And so I was dealing with web servers. The first one was Apache HTTPD. Then I came and found the Modcache plugin for Apache, and that's where I knew about the caching for web servers. And then, again, caching with more complex backends when the application became a little bit complex with session, and then over time when you had to deal also with authentication authorization, with OTP, one-time passwords, still inside the cache. So that is cache where you can find a cache. And another one is when you implement and develop your backend application, when you actually need to interact with data, with databases, that you probably, and you of course need a framework such, I don't know, Hibernate, Spring Data, or MyBodies to access the data. And that's where you also find a cache as a cache, again, level 1, level 2, to access and store the data locally and without accessing to all the time to the database. And just a few recap where we are, now with software architecture before we deep dive to the caching solutions. And we all know where we come from. We come from the monolith applications where all the pieces, function, capabilities of a software was just in one single application. And when you had to actually scale this application, you had to scale the entire thing, not just the capabilities, not just the feature, etc., which is the monolith approach, so scaling everything at once. Then we understood about microservices approach, a different architecture where you actually break down your monolith in different pieces regarding, I don't know, for functionality, capabilities, domain, for business. And so you have all these single services that you can scale for reads, for writes, for scalability purpose, for throughput, etc. So you just scale what actually needs to be scaled and not the entire thing. And when it comes to caching, again, for microservices and monolith application, all the time we were interacting with a monolith database. Still today, most of the bigger companies, they have those legacy big database. They didn't split the database, for example, with in different technologies like NoSQL or relational database or column-based database, etc. They still have most of the time relational database as a monolith, but the application now are served as a microservice. And you can actually have reduced the workload on the database level by introducing a caching solution. And you have two different approaches to do this. You can have a collocated cache with your microservices, where each microservice then has its own cache collocated with the application, which then interact with the source database, which is, as we all know, is the source of truth for the data, for the client. But those caches, as you can see, need to sync to the database. So if something is missing in one microservices, if something is present in a cache in one microservice, it doesn't mean it's also present into the other collocated cache in a different microservice. So each microservice has its own cache, and this can actually hit the performance of the database. And the database can be impacted for this. Just imagine if, I don't know, if you need to sync a data on these orange microservices, and the same data also is needed by the green one on the purple one. They will all go to the database, fetch the data, put in the cache, and so the database will suffer for this. Another approach of using a caching solution is to use a distributed cache. So with this approach, each microservice points to one distributed cache. And by distributed means we distribute the workload of our caching layer, and the only one that is interacting with the database is actually the caching solution. So as you can also see from this picture, if something happens bad to the cache, we will have an impact on the database. Imagine there are not just 3 microservices, maybe a bigger, a wider architecture with tens of hundreds of microservices all interacting with the caching. If the cache goes down, the database will be impacted, and sooner or later the database will collapse. So the cache solution is also very important for performance, for throughput, for ingestion of the data, pretty much for everything. And if you have client-facing applications, I'm sure you need a caching solution to interact with your front-end application. And let's see how we can implement a caching solution at application level. So which patterns we need to follow and follow those best practices to interact with the caching solution and the databases. So those are the list of the most commonly used caching patterns: cache aside, read through, write behind, refresh ahead, and read replica. There are others as well, but the most common ones are those 6. So let's start with the cache aside. Here on the right, we have a sequence diagram where the client is actually your user. Can be an application, can be a front end, and sends, in this case, a request for data to the backend. The backend then forwards this request to the cache at first. If the cache has the value, will be returned, and then, of course, the response will be forwarded to the client. But if the cache doesn't have the data, the application will need to fetch the data from the database, get the data, put it back into the cache, and then return the value to the client. This is called cache aside or lazy loading pattern. And at application level, you can easily do this with few annotation. Probably, or at least in Java, you can use, for example, the Spring annotation, where you annotate your class with caching config, where you specify the name of the cache, and then for all the mutable and immutable operation or methods, you're going to just put the annotation such as cacheable, cache puts, for mutable operations such as create, update, and delete, and cache evict if you need to delete information from the database and then, of course, from the cache. The one thing is that thanks to Spring, all these, whenever those annotations are intercepted by the framework of Spring, The method, your business logic, of your method will only be executed if that condition on the cacheable annotation is met. So if there is no data on the cache, then the method will be executed. Otherwise, it won't be executed and the data will be returned. Another caching, so as you can see, it's very easy. There is no magic behind, apart from the one that does Spring for you, but from implementation, it's very easy. The other technique or pattern is the read-through, where still we have pretty much almost the same sequence diagram, a client asking for data to the backend fetches the data from the cache. If they are not available, this time is the cache provider that interacts directly with the database, fetching the data, setting the data inside itself, so in the cache, and then returning the value to the backend and then to the front end. So this will, for the application and for the developer, it will be transparent. There is no linear code to, like as we did with the cache aside, to implement some specific logic. Then for mutable operations such as the writes, we have this pattern which is called write-through, where again we have pretty much the same actors in our sequence diagram. So the client, the front end interacting with the backend, and then the backend will write data to the cache, and then we'll also write the data to the database. This is also called, I know it's a caching pattern, but this is basically it's a dual write, which is an anti-pattern. So we don't want to do dual writes. We want to have a different approach. And another variant of the write-through is the one that moves the logic from the application to the cache provider. So if you can, as you can see here, still the front end interacts with the backend sends the request to the cache provider, and then the cache provider writes the data to the database. So at the application level, there is no logic that you need to implement, so you will not need to do the dual write. Now we have the write behind, and let's see if you can catch the difference. Did you catch any difference from the previous one? It's just about the arrows, that on the right, there are open arrows, which means in UML, which is an asynchronous communication, asynchronous interaction. That means that when the backends interact with the cache, it will be a kind of fire and forget operation. So we'll send the request and we'll immediately have the response from the cache. And then asynchronously, the cache provider will set and will write the data to the database. Which one is better? As usual, it depends. The first one, the write-through, is for consistency. So if you need consistency among your caching layer and your data layer, so your database, you need write-through. If you need performance, write behind. It's just a matter of a few milliseconds, and the data will be updated into sync between the cache layer and the database layer. And there are caching solutions that are smart enough to also provide consistency for the asynchronous communication because they are based on streams. So all those events of writing operation will be set into a stream or a queue, and then later on will be picked up by one of their scheduler, and so that can work and process the write to the database as well. The purpose of the cache is to serve data as soon as possible, but sometimes the data are not available in the cache, and the most desirable feature for a cache is that can update itself automatically. And this can be done in the last two techniques that I will show you. Refresh ahead. As you can see, we have now it's more complex, this sequence diagram, but still very easy to understand. we have the front end interacting with the back end, which will then towards the request to the cache, like reading data. At some point, this data, it might be changed at the database or might be not more available because it was marked like with a time to live, so as expired. A smart cache provider can intercept those expiration events, so whenever the data in cache gets deleted, will trigger some codes that goes back to the database, fetch the data again, so the new value, the updated value, and then put it back in the cache. So the next time a client sends a request, we'll read the updated data. The refresh ahead is also used for when you have a caching solution, mainly, which means 99% of the time, for reading. Then what you should do is implement a refresh ahead that you do an offloading of the database towards the cache. So in that case, also the refresh ahead pattern is used. However, if you didn't set any expiration, any time to live to your data into the cache, and something happens into the database layer, which means someone externally updates the data, then you want to be notified about this change. And that's what the pattern to use is the read replica. The read replica is very similar to the refresh ahead. The difference that is based on the change data capture solution. So again, a smart enough cache provider will have a CDC implementation, which can have a bunch of connectors that can interact with the database, intercept the changes, grab those changes, fetch them, and then update the cache automatically. So in this case, the front end, the back end, they only interact with the cache, not to the database anymore. And there are many implementations of this read replica. One of these is, you may know, is the one, the open source project from Red Hat, which is Debezium, and which is also used by many cache providers. And it's very easy, but gives you this kind of capabilities. Now let's see a quick demo. I implemented a couple of patterns just to make everything easy. I didn't implement the last one, the read replica based on CDC, just to set the expectations. So let me switch. Yes. I will first prepare everything and then I will increase the fonts, don't worry. So I will start here my Docker container for the cache solution and another one for my database. And in the meantime, I'm going to copy my business logic to the cache provider containers. Okay. And then let me go to my list of commands that I need to use. Okay, let's grab this one. Okay, so here, I don't know if you can see it, but this one we can. So here I'm using Redis as a cache provider, of course. And I just uploaded my business logic to do all I have all the interceptor to capture all the notification regarding my mutable and immutable operations, so for reading and writing. And in this case here, I uploaded my person as a model for my domain right behind pattern. And I have also write through, which as you can see above, it gets registered on the cache provider. and then the person read through. Okay. So whenever we interact with the cache, we may also write to the database, and we also may automatically read new data from the database. So let me show you. Okay. This one. Can see it good? Okay. So I'm going into the CLI. This one was MySQL. Show databases. Okay, use DDT. Okay, show tables. There's nothing. On the Redis side, let's see. Keys. Okay, it's empty. So both the database and the cache provider, the cache are empty. So now I'm going to try to set few data into the cache. And I'm going to copy and paste my command to do that, which is I'm going to use an hash as a data structure, so a list of field and attributes pairs, and based on the key person with ID 1, name Luigi, last name Fugaro, age 44. And what we should see now is few logs here on the cache provider, and then we should find the data also at the database. Okay, so first, on the cache provider, we have seen that we actually received an output, a response of 3. That means I wrote 3 attributes into my cache with key person 1, and it took almost 3 seconds. Those 3 seconds are given by all these things that happen at the cache provider. So my interceptor, person write-through records, and then interacting with the database to store the data both at the cache level and also at the database level. And it took 3 seconds. And now, if I see into the database, there is my table person, and select star from person, I can see the data. So from the application perspective, from the backend, I didn't write any line of code. Everything happens at the cache provider. Now, let me try the right behind, which is the asynchronous propagation of the data from the cache to the, yes. Is the Redis?
The application that is logging in the top terminal.
Yes, it's Redis.
It's Redis, okay.
Okay. And so let me try now the right behind. So with the asynchronous communication between the cache and the database, I'm gonna do this by, I use another key pattern just for the example. And I'm going to set it as 2, same. So as you can see, it's still doing something at the top terminal, but it took probably less than a millisecond on the cache level to execute my write. That's the purpose of the right behind performance. So the application, it will have the response in less than a milliseconds, and in the meantime, the cache provider will take care of the synchronization of the data from the cache to the database. And again, we can see here that my right behind interceptor started and then executed all the logic to persist the data back to the database. Again, without having nothing at the application level. Now, and we can see, of course, that now I also have the other record on my table on my SQL. Now, what happens if I do an insert? No, let's do this one first. Now we just wrote data. What if we read data and the data are not in the cache yet for any reason? What we can do is to use the fresh aheads, the read replica, and the read through pattern. I implemented the read through, which basically, if the data is not found in the cache provider will fetch the data from the database. So, and the interception points in the cache is what we call cache miss. So we didn't find something into the cache. That's the event to apply your business logic. So let me insert into person values 1, 2, 3, 2, 2, 4, and should be it. Okay. Okay, now we have record 1, 2, 3 into the database, and if I go and see into my cache, we only have person 1 and 2. There is no notion about 3. What we can do though is to have the hget, which stands for hash get key 3, and just, I don't know, just the name, for example. In this case, we should see at the cache level the logic to fetch the data because it's not found into the cache. Now, okay, the read-through interceptor started. It has interacted with the database. And now if I go back here and show the keys, now we also have person 3. So, as you can see, for reading, for writing, you can rely on the cache provider to implement that logic. So you don't need to also include this logic at your application. Your application can remain the same, but still have performance thanks to the a caching solution. Going back to the presentation, those are the implementation details. So how I did it? Let me first show you, not the code, but at least, I don't know if it's visible. It's Java codes where I had to, like, the person read through. That's how it looks like. Just extending class, and then the business logic on the on-process event. The same applies for the write behind with different logic and the write through for different logic. But we also have, I don't know, for example, I also implemented the catch all just for debugging purpose, to see what kind of notification I was receiving from the cache provider. And that's it. And on the solution level, that's what I've been using. Redis as a cache provider, and then as a serverless engine, Redis Gears, which implements an engine for C, Python, and JVM languages. So Java, Scala, and Kotlin. So you can use all your logic that you have already implemented with those programming languages. JavaScript is also coming, and you can see the power of using the cache providers also to fetch the data automatically from the database. And yeah, that's it. I don't know if you have any questions. Otherwise, thank you very much for listening and for coming to listen to my talk.